TechTO is an AI-powered digital twin for the city of Toronto. It answers a question traditional planning tools cannot. So if you change something in the city, how will the residents actually respond? So now we'll ask our model this. And at the center of is our backward planning orchestrator. So instead of relying on one general purpose agent, TechTO coordinates 11 different specialized agents. And let's start by one of them. So the city co-pilot understands the planner's question and manages conversation. We have orchestrator, which turns into operations on the digital twin. We have geospatial twin, which modifies transit networks, land use, and city geometry. We have a scenario designer, which creates multiple policy alternatives and counterfactuals. The citizen response agent, which estimates how different populations would react. We have an equity impact agent, who identifies who benefits and who may be left behind, including some low-income riders, seniors, and mobility device users. The feasibility agent also calculates life cycle costs, vehicle hours, fleet train, carbon reduction, and many more. We have an independent reviewer with memory disabled, so it attacks the proposal using hidden stress tests. We have also an evidence auditor, which rejects claims that cannot be traced to a real tool output. And finally, the system ranks the options and returns a clear recommendation, including any condition that risk planners should consider. So Backboard turns this question to a structured, multi-agent planning workflow. But these decisions are not only technical, they're human. So every point on our map represents a grounded resident profile built from over 165,000 individual records in Stats Canada through their census files. We then look at those records across all the neighborhoods and incorporate different political attitudes from the election study. We then supervise a model using more than 32,000 real human responses from various consultations and open-ended surveys, then calibrated it using reinforcement learning through group relative policy optimization. So this model generates an opinion and compares the response against patterns in real survey data across similar demographic groups. Responses then align more closely with observed human preference to receive a stronger reward, helping the model produce more plausible perspectives over time. So the key insight is that TechTO does not only output an approval scene, it provides a human readable reason behind every prediction. We also use MongoDB Atlas as the backbone, so vector search finds neighborhoods using natural language descriptions. We have full text search, which resolves TDC stops and routes. We have geospatial indexes, which connect train infrastructure, demographics, and other communities. So on the front end, we use MapLibre, which renders the Toronto as an interactive 3D city. And our simulator models various boarding, wait times, and reliability as well. And that same platform also evaluates various opportunities to reduce kilometers in transitions. So this means sustainable policies, transit expansion, bike lanes, and etc. Now, every TechTO decision is auditable, so planners can also replay this entire agent timeline inspect through a tool call. They can review evidence and also a citation-backed policy report. TechTO obviously does not replace public consultation, but it does give planners a better census-weighted, reinforcement-calibrated preview of how Toronto may actually respond, with a clear reason behind every prediction, so they can improve sustainable proposals before taking them to the public. Thank you.